wish we'd get another seat cover.
Well, how much energy is needed to raise the temperature of a substance a certain number of degrees? As we saw in the examples, everyday experience tells us it can't be the same for all substances, like the water or the substances in this egg. Specific heat capacity is the quantity of heat that is required to raise the temperature of a unit mass of a substance 1 degree Celsius. Now, what does the average person know about specific heat capacity?
Here we have a sample of iron and water, both of which have been in the sun for the same amount of time. Excuse me, sir. We're trying to find out whether people think iron or water has a higher specific heat capacity. Could you help us out?
Sure, try.
Okay, now all I need you to do is touch the iron, and then touch the water, and then tell me which you think has the higher specific heat capacity.
Well, I take a guess at iron.
Iron.
Iron?
Which one's warmer?
The iron. Okay.
The iron.
I say the iron. Okay, and you?
I say the water.
And I'm supposed to tell you which is the higher specific heat capacity. Which one do you think can hold the most heat?
Most heat. Okay, I think the iron can.
The iron?
Yes.
Okay. And you, sir?
Water.
Water?
Easily water.
Okay.
No, it's got to be the iron. Forget it. Look, it's a lot thicker. It's a lot heavier. More heat could go into this.
That's all from here. It seems most people think that iron has a higher heat capacity because it's warmer.
So most people think that iron has a higher specific heat capacity than water. But gee, I've got a simple little analogy here that might shed some light on the matter. I've got two different containers, and one's going to represent iron and the other water. So what do we know about the iron and the water?
Well, they both have the same mass.
Exactly. And this colored water is going to represent the energy that I'm going to add to both.
But we don't know the amount of energy absorbed from each substance.
That's true. We don't know the specific quantity of energy absorbed by either the iron and the water, but we know something is comparatively true.
Well, they've been both sitting out in the sun for a while, so they should absorb the same amount of energy.
Exactly. And that's why I'm pouring the same volume of water. Equal volumes of water will represent equal quantities of energy added to both the iron and the water. So, as I'm pouring, what happens to substances when we add thermal energy?
Well, it gets hotter, so the temperature rises.
Exactly. And if we look at this, we can see that the temperature has obviously risen much more in this container. So what does this represent?
Well, iron's a warm substance, so that should represent the iron.
That's right. This is the iron. This is the water. I've got something to show you, though. Drum roll, please. Select. All right, there's the water, and there is the iron. Okay, iron. Set that down there beside that to represent the water. And the volume here means something to us about the quantity of energy that each can contain. So what do you conclude?
Well, the water obviously holds more energy than the iron does.
Exactly. The water has a higher capacity for storing thermal energy. And this relates to specific heat capacity, which we define as the quantity of energy necessary to raise the temperature of a measured mass of any substance by 1 degree Celsius. And in the case of the water, it takes 4.19 joules of energy to increase the temperature of 1 gram of the water by 1 degree Celsius. Whereas for iron, it only takes 0.444 joules to increase 1 gram by a degree Celsius. So even though I added the same quantity of thermal energy to each of these, the fact that the water has such a much larger capacity for storing energy means that its temperature did not increase by the same amount.
I'm here at the Weather Center where we can gain some insight on another consequence of water's high heat capacity: climate. Claire, what effect does large bodies of water have on climate in summer and winter?
An easy way of looking at this is to regard it from a weather standpoint. And here in the weather business, we call that continentality. How far you are from the water itself determines on how your temperature is going to be, your climate is going to be over a long period of time. Water specifically has a cooling effect. It tends to moderate the climate, keeps the temperature stable rather than allowing wide fluctuation. Prime example of that is Alberta. We generally see plus 30 in the summer, minus 30 in winter. Go over to, say, somewhere like England, which is surrounded by water, they'll never see temperatures like that. They have a far more moderate temperature regime.